so let's say that for this problem, I want you to write the overall reaction, and I give you basically a metal and a metal ion, another metal and another metal ion, lithium and gold. And I want you to write the balanced overall redox reaction. And to do so, we obviously need to use table J, and you have to remember that you have to conserve both mass and charge when you do this. So, our first step, I just heard you say it, Kaylee, we need to determine which one is our anode, which one is our cathode, because that'll help us know which one is oxidized, which one is reduced. How do we determine the anode? Table J,
yeah.
And the one that is higher up. Good, so the one that's higher on table J, which obviously is which one? Lithium, because if you notice table J, that is the absolute highest or most active metal on table J. So we've got this super active metal and then this super non-reactive metal down here. So we're at two ends of the spectrum. Okay, Cassie, go ahead and write our oxidation half reaction for this cell. Start with your lithium. Yep. Yep. Sure would. Li yields Li plus 1 electron. Remember, we put the electrons on the right because we're talking oxidation. Rowan, write our reduction. Great job. Au plus 3 aqueous yields, plus 3 electrons yields Au. Okay, now, if we want the overall reaction, we've got a problem here. Both of these are written correctly, but before I can add them, what step must I do?
You have to multiply lithium by 3.
I have to multiply the entire lithium by 3, and what is the reason for that? I've got to get my electrons lost equaling my electrons gained. So I get 3 Li solid yields 3 Li plus 1 aqueous plus 3 electrons. Now, I'm able to bring one of the reactions under the other, and I can add them. So let's do so. Au plus 3 electrons yields Au solid. What cancels?
The 3 electrons.
Very good. 3 electrons get crossed out, and now I can write my overall balanced equation, and we will check it at the end to make sure that it has conservation of mass and charge. Okay, so we can go ahead now and put in our phases, anything aqueous, or as an ion is aqueous. Au is solid, and we'll notice here we've got 3 lithiums, 3 lithium ions. 3 gold ions, 3 gold atoms. Good to go. Let's check our charge. Plus 3 on the left. 3 times plus 1 is plus 3 on the right, and we're good. Most people do pretty well with that type of question. The next one is where it gets some people. We're going to do the same thing, but this time it's the ladies' turn, the non-metals.
Okay, this is the one I need help
I was going to say, this is the one that if people mess up, it's generally when we have the singular replacement Sadie Hawkins dance involving these. So here we go. I'm going to give you 2, thank you, atoms and ions. So we will do something that looks like this and something that looks like this. I want you to do the same thing, write the balanced redox reaction. Now there's a whole lot of similarities to what we just did, but there are also a few differences as well. So the first difference that I really need to key in on is the one that is higher on table J. Does it get oxidized or does it get reduced? The one that is higher on table J is going to get reduced. Very good. That's really important to know because we did it the opposite way, all right, before. The one that was higher on table J for the metals got oxidized. So we've got our oxidation, and we have our reduction half reaction. So which one is higher up? Definitely the chlorine. Chlorine is higher on table J. So we know the chlorine and chloride ion are going to go over here on this side. We know that our oxidation, our I2, and our 2I negative are over here. Now, Kaylee, I know where you're in your mind, at least I'm pretending to know, where you're saying, I have a troubling spot. And here's what it is for most people, because I know you said you needed help with this. It is probably saying, which one of these do I pick to start with? Do I pick with the I2 to start with for oxidation, or do I pick the other one to start with the oxidation? Now, you've got to think about this. Which one of these has electrons to lose? The what? 2I negative. Absolutely. The 2I negative has extra electrons to lose, so we're going to start with the I negative. You answered it right, but you wrote it wrong?
Yes.
Okay. We're going to change that to what? I2 plus 2E. Very good. That is our oxidation half reaction. You got to remember is that on the other side, we're reversing everything. On the other side, let's go to it. We said the one that is higher up on table J is the one that gets oxidized. Think about what happens here. You're going from Li to Li plus, not negative. So the one that has electrons to lose, in this case, is the atom. Over here, you're talking about a negative ion in the atom, so the one that has electrons to lose is the ion. So you start in two different places. So here we start with the ion, and we form the iodine molecule and release two electrons. Can someone over here do my reduction for me? Yep. You got it. This time, we've got to have the atom, which is the molecule, pick up the two electrons to form the ion. So this time, we start with the molecule and form the ion. Okay, I'm ready to add them together. Do I have to multiply through by anything? Nope, good to go. So I'm just going to move my Cl2 reaction underneath. So we get Cl2 gas plus 2 electrons yield 2 Cl negative. Cross out my electrons. I get 2I negative plus Cl2 gas. Aqueous here yields I2 gas plus 2 Cl negative. Sure, we can do another. And that would be my total balanced equation. You want another one involving nonmetals?
Yeah.
Okay. So another review here involving nonmetals. Why don't you do this for the following? Br2. I'm going to make this one. You're going to have to do the balancing on your own, okay, to make it more realistic. And we will do F2, F negative. This is Br negative. All right, so I'm going to let you balance this on your own. I'm giving you bromine and the bromide ion, fluorine and the fluoride ion. You use this exact setup above, reason by analogy, to figure out and write your overall reaction. You're going to need an oxidation half reaction, and you're going to need a reduction. volcanic reaction. What I want you to do is I will work the problem out up here. Don't look at it until you're done. Try to work it all the way through on your own, then look up there and I'll come around to help those who might have a question. First step, remember, is to identify which one is higher up on table J out of these two, and the one that is higher up is the one that will get reduced. Get over there, Faith. See if you can probe the depths.
Okay. So what I do, I just erased it all. But I don't
Great
understand
question.
from the start.
First thing you're going to do is
So I always end up with the ions on the same side.
charge. So before you get to this, go back up. See, here's your problem.
Right.
See how you have BR2 here, but you only have two, one BR here? You got to add a 2 there. Okay? Now, if you want to take, that's right. If you want, you've got to lose 2 negatives to make this, both of these BRs go from -1 to 0. Remember, your oxidation number on this is 0. Here it's -1. There's 2 of them. So to make one BR negative goes to go to BR 0
Oh,
and
okay.
lose 1 electron. To make 2 of them, you have to lose 2. So the same thing here. You've got 2 up good. You've got 2. So to make 2, to make both of these F atoms become
Yeah.
2
So
F
then, like
negative,
when you do
add
this,
2
I started with the F2, but that does that mean that it would yield 2
I have a
F negative
question.
plus 2 electrons?
Coming over. Be right back.
For the second part, I did the BR2 plus 2. Is that fine?
You did what?
Over here. I switched
Oh,
them.
okay.
Perfect.
Okay, that makes
No
sense.
problem.
Thanks, Faith.
Cassie, you cannot use your phone in class.
That's what I'm doing it for. Look at chemistry.
You're texting.
Well, I can't do chemistry on my phone, so your choice.
Oh my goodness.
Paper.
I don't have a pencil.
Cassie.
Okay.
Easy.
You could lock it at least so it doesn't die. That's why it's plugged in.
Cassie, watch your language, clean it up. The twos, good question. Look what's happening right here. BR2, you have to balance your BRs. So always balance your atoms first. So 2 BR negative yields BR2 plus 2 electrons. Over here, you have the same thing, and that's why you have 2 electrons. Make sense? Okay.
Hang on, don't go over it yet.
Did Faith help you out?
Yeah.
Good. What's that? Oh, thank you.
Okay.
If we don't put our phases on the test, we're gonna get them wrong.
You should always try to remember phases. Depends on the question.
I got it.
Okay. Now, let's go back and see if you can do a hookup problem. Okay, so a quick review hookup problem. Here's what I want you to do. If I give you the following, Mg plus H2SO4, solid aqueous. You have a couple things. The first thing I want you to do is finish the problem. Okay, identify what type of reaction that is. What is it? Okay, so can someone finish it for me?
H2
Yep,
plus
very good.
MgSO4.
How do we know it's MgSO4 and not like Mg2SO4?
Because of the crisscross.
Yes. So Mg is plus 2, SO4 is negative 2, crisscross to get Mg SO4. Someone might say, well, why is it not Mg2 SO4 in parentheses 2? And you would say, we cancel out the 2's because it's ionic. Very good. And we have one other issue. We need to know the phase of MgSO4. Where do I look?
Table.
Table F. Good job. You guys are getting these down. Table F. Find sulfate. Are we with calcium, strontium, barium, or lead? The answer is no. We are aqueous. Are we balanced? Beautiful. Okay. We need to do some hookups with oxidation numbers. So we want to figure out, the question is, I want you to determine the reducing agent and the oxidizing agent. Now remember, you never answer that question directly. What we really want to know then, what we're going to try to find is, what is oxidized and what is reduced? Because if we know that, whatever is oxidized is the reducing agent. Whatever reduced is the oxidizing agent. Okay, here we go. Hookups. Give me some numbers. Mg is? 0. Hydrogen?
+2. Well, +1.
Good. +1. Total oxidation charge is +2. Oxygen?
-2.
Total oxidation charge?
-8.
Sulfur must be? +6. Good. Hydrogen stands alone? 0. Over here, Mg? +2. Sulfur?
+2.
Should do oxygen first. Good. -2, -8. Now sulfur's easy. +6. Good job. Okay, we've got our oxidation numbers assigned. Now we look for what goes up, what goes down. That's going to tip us off with our Leo and Gur. What goes up?
Magnesium.
Sure thing. Mg is going to represent our Leo, Ra, up and right. What goes down? The H2 goes from +1 to 0. That represents our Gur, OA, down and left. Now, can someone tell me what is the Ra? The Ra is certainly the Mg, and be careful with the OA. Hi.
H+.
That's okay. The OA is the H+. Hi.
Hi, I had students exposed to poison ivy first period.
Yep.
And do you have any alcohol that I could borrow? Because I need to disinfect the room.
Ooh.
And the nurse tells me alcohol is the only thing that will get rid of it, and she
Okay.
doesn't have any.
Yep.
So this nurse suggested I come and
I
see
do.
you.
I assume you
Oh,
want
no.
Yes, rubbing alcohol would be preferable.
Where did they
And this is
go?
all Joel Fisher's fault, but he's in the meeting, so I get to clean it up. You signed. I have no idea. The nurse, this.
Where do you think you got it?
I don't even know. I don't know.
How do you know you got exposed?
Because the nurse told the kids that came up to her room second period that they had poison ivy, and most likely it was from going out with Joel to clean up stuff. Because they didn't have it last night, but now they have it. Weird, huh?
I don't think it's going to be transferred that much, right?
Well,
I mean, I know that I guess if you get oil on it, it could, but
yes, I agree with you, Mr. Cook.
Good
but
luck.
I was told to disinfect. Yeah, it's your father.
get
I was told to
disinfected.
disinfect where these students touch. Thank you.
You're welcome.
She cried.
It has. Okay, lastly, let's end with this. Write the oxidation and the reduction half reaction.
Oh, gosh.
Write the oxidation
Okay.
and the reduction half reaction. Now remember, once you have your hookups, this is fairly easy because you just follow what is being hooked up.
I gave her, like you didn't ask Cook?
I gave her what I had. I think between the two of us, we'll get her covered.
Yeah. Well, she actually got some from Schimmel. He had some.
Oh, cleaning
Yeah.
keyboards maybe or something. I didn't have a whole lot of rubbing. I have a lot of ethanol.
Right,
or-
which I assume would work just as well.
I gave her the rubbing I
don't
had,
think
and
I
then
have any rubbing
if she
alcohol.
needs more, I'll.
I have ethanol too.
Yeah, I think it would kill just as well too.
Acetone. I mean, we probably kill.
We could kill them all and give her sulfuric if we need to.
Kill it all.
All right, who's got the oxidation? Who's got oxidation?
Zoe said Zoe.
Zoe, go ahead.
Mg
Yep.
yields Mg +2 +2.
Awesome job. Who's got reduction? This one's a little bit harder.
It's
Careful with your balancing. What is the yield on this side? Just follow your hook up. Just H2. Yep. If you can do that, you're in good shape. And we'll end her there.
Shoot, this
Tori
wasn't my
is
fault.
amazing. That's what your desk says.
He sits there and he's